Hello, Algebra 1 friends. It is wonderful to quote unquote see you. I hope that you're well. Let's do a little math, shall we? Start by pausing this video and work out this little problem right here. Go. All right, I hope you took the time to work through this. It is a really good idea to do these problems as a warm-up, and then when we talk through them together, check your work. Because if you're right, then yay, you can confirm that, and if you're wrong, you can see where you made mistakes. Checking your thinking like that, trying something before you have it confirmed is a great way to learn. So the idea is we want to know if x equals 2 is a solution to this equation. In other words, if we drop a 2 in for x, will our equation be true? Will it balance? So let's just do it. That's what we do to solve this problem. So if we take 6 and we drop that 2 in for x and we add 7, are we going to get 19? And let's put a little question mark over that because we're not really sure yet. So 6 times 2 is 12. Plus 7, is that the same as 19? Yeah, it is. And so since we have 19 equals 19, a true statement, then the answer is yes, 2 is a solution to this equation. And so when you're working with equations, you can work with them a lot of different ways. And what we've been talking about lately is about functions, because we're going to start, and then we talked about linear functions and how you can recognize them. Now we're going to start talking about graphing them and being able to find their solutions. Work with dropping numbers in for x and having things happen is a skill that you're going to need. So great job. So how about you update that notebook, get a page ready for today's notes, write questions in your last set of notes, write a summary for the previous set of notes, and then come on back and we'll do this. All right, the essential question today, how can you use a table to graph linear equations? The topic, graphing linear equations using a table. So let's get started. So in the warm-up, we saw that we could enter a value into an equation and see if that value is a solution. So if we're being told that x has a particular value, we can plug that into an equation and see if it works. We can do the same basic idea to create the line that an equation represents. In the last video, we talked about the difference between linear equations and non-linear equations. And basically the idea was that an equation is going to be a linear equation if it makes a line. And now we're going to be actually making those lines because every equation can be graphed. Linear equations make lines. The word line is right in that linear part. So linear equations make lines. A graph is basically a picture of an equation, and a graph can tell us things that an equation does not. An equation tells us a certain part of the picture, but if you actually have that graph, the line that the equation represents, then you can see many more solutions. You can see a picture of the solutions of that equation. With an equation, you have to solve it every time to find the solutions. With a graph, you can just see them. So we can turn graphs into equations a few ways. There's a variety of methods, but I don't want to do too many at once. Today we're going to be looking at one way, making a table. So here's the basic idea. If you want to graph the equation x plus y equals 4, then the first step is to make a table using random numbers for x. So here's what I mean. Typically, you'll see a table that looks like this. And you've got x values and y values. Now remember back when we were talking about functions, how x's are inputs and y's are outputs? That's because you can take numbers and just whatever number you want, just random numbers for x, and input them into the equation, and see what happens with y. Okay? So x's are inputs, y's are outputs. So here's how we can use a table to graph this equation. Let's just pick a number, any number for x. And you literally can do this. You can just pick any number at all. So let's pick the number 1 for x. What we're then going to do is take this equation and drop 1 in for x, plus y equals 4. Now we have to solve this equation to see what the value of y is. We have inputted the 1. We're going to solve it to get the output that y is. And this is how solving equations comes in handy, because now you just subtract 1 from each side, right, to create that cancellation, and you have y equals 4 minus 1, or 3. So when x is 1, y is 3. And then you just pick another number for x. It really doesn't matter what it is. It doesn't matter if you pick numbers in order. I suggest like a couple of positive numbers, a couple of negative numbers. I also suggest 0 is a good one to pick. So let's try 2 now. Let's say that x is 2. That means that our equation would turn into 2 plus y equals 4. We have inputted the 2, and we're going to see what we get out with y. So again, we're just going to subtract from both sides using those solution techniques that we practiced last semester, and we have y equals 4 minus 2, or 2. So when x is 2, y is 2. And this is how you make a table. Now let's go a little bit faster. Let's choose 0. X is 0. Then we would have 0 plus y equals 4, because we're dropping that 0 in for x. Subtracting 0 from both sides gives us that y equals 4. So when x is 0, y is 4. Let's try a negative number. Let's try negative 1. So now we have, and this is getting a little bit messy. Sorry about that. Negative 1 plus y equals 4. Well, we have to add 1 to both sides to make that cancellation. These cancel, and y equals 5. So when x is negative 1, y is 5. And let's do negative 2, just for one more chance at looking at it, and then we'll erase some of this mess. So we have negative 2 in for x this time. Negative 2 plus y equals 4. Adding 2 to both sides to create that cancellation gives us y equals 6. Great. So when we inputted negative 2, the output was 6. Let's get rid, oops, let's get rid of a little bit of this so we don't have such a mess. There we go. So that's how you create a table. You just pick a random value of x. I suggest some positive numbers, some negative numbers, and 0, because that just kind of gives you all different types of outputs. Plug that into the equation for x, solve it for y, and you're good. Now the next thing you're going to do, we've taken care of this part, the next thing you're going to do is plot the points. Now each one of these is an x and a y value. See how you get 1, 3? That is a point that you're going to plot. You get 2, 2. These are points. 0, 4. See what I'm getting at? So let's plot this on this little piece of graph paper. So 1, 3 is to the right 1 and up 3, so it lives right here. And then 2, 2 is to the right 2 and up 2. There's 2, 2. And then 0, 4, let's see, we don't go anywhere on the x-axis, but we go up 4 on the y, so there we go. And then negative 5, so negative 1, so to the left 1, and then up 5 here. And then negative 2, 6 up here. And notice how every single point lined up, because this is a linear equation, and its equation will always make a line. Now hopefully I can do this straight. Oh, that's not too bad. And we can indicate that line by connecting those dots and then putting an arrow on either end. We can connect these points with a line. The reason why graphs are so useful is now when you look at the equation x plus y equals 4, that's all very nice, but it's very hard to tell what the solutions are. Now you can look at this graph and you can pick out an infinite number of solutions for it. You can get some x values, some y values, and you know the numbers that will solve this equation, that will make it true. If this were a real-world situation, kind of a equation being used in the real world, now we could use it to make predictions about a situation. We could see what things happened in the past as a result of this situation. Graphs are very, very useful, especially linear ones. So that's basically how you do it. You make a table using random numbers for x, just make it up. Once you do the inputs and solve for the outputs, then you're going to plot those points and then connect those points with a line. So let's try it again. Let's do one that's a little bit trickier. Let's do 2x minus 1. Now let's make our table. And you don't have to have a bunch of points. You just kind of want to see what's going on. Here's x's and y's. And our equation is y equals 2x minus 1. So let's start with negative 2 on this one. Let's just play with negative 2. That means that y equals 2 times negative 2 minus 1. So y equals, well, 2 times negative 2 is negative 4 minus 1. And that means that y equals negative 4 minus 1, which is negative 5. And so when x is negative 2, y is negative 5. Let's do it again. Let's choose negative 1 for x. So now we have y equals 2 times negative 1 this time minus 1. Y equals 2 times negative 1 is negative 2 minus 1. So y equals negative 2 minus 1, or negative 3. So when x is negative 1, y is negative 3. How about 0? I'm going to draw a line here and separate these out a little bit. So when x is 0, we have y equals 2 times 0 minus 1. Well, y equals 2 times 0 is 0 minus 1. So y equals negative 1. So when x is 0, y is negative 1. Let's just do one more. Let's choose 1. We won't worry about this one because we don't want this video to go on forever and ever and ever, do we? Y equals 2 times 1 minus 1 this time. So y equals 2 times 1, which is 2 minus 1. And 2 minus 1 is 1. And so when x is 1, y is 1. All right, let's plot these as points. We want negative 2, negative 5. So we're going to go to the left 2 and down 5. There it is right there. And then we have negative 1, negative 3 right there. And then 0, negative 1 is here. See how they're on a line? It'll work like that every single time. And then 1, 1 is here. And oh, by the way, this would be a solution as well up here, because that's the way the line's going to go. I mean, we can pick out any number of points now that exist on this line right here. And now we have the graph of this equation. So we made a table using random numbers for x. Takes a little bit of calculating. Sometimes, like in this one, you kind of have to use those solution solving techniques that we talked about in semester 1. Sometimes it's just some pretty basic simplifying of math, but then you take the points and you plot them, and then you connect the points with a line. Okay, let's try these because these are a little bit different. So this number 1 says y equals 1. Okay, well, we're trying to make a table here. So let's see. Got our x values, we got our y values. Now notice in this y equals 1, there's no place to input values for x. It's almost like they're saying we don't even care what x is. y is always 1. And that's actually true. That's what y equals 1 is trying to tell you. It's a line where y is always 1. And it doesn't matter what x is. Y will always be 1. This could be, 101. And it wouldn't matter. Y is always 1. So these are kind of easy because there's not even an equation to plug into. There's really one step, just recognizing that no matter what x is, y is always 1. We can plot that out. So let's say -2, 1. So we've got -2, which is 2 units to the left, and then up 1. There's that. And then -1, 1 is there. And 0, 1 is there, and 1, 1 is there, and you can start to see this line is going to be everywhere in the world on this graph where y is 1. Even in between things would work. This line is what y equals 1 looks like, because it's everywhere in the world that y would equal 1. Let's take a look at number 2. This is sort of just the opposite idea. Notice in this equation, we don't have anything going on with y. Again, it's almost like they don't care what y is, and in fact, that's the case. It doesn't matter what y is as long as x is always 2. And you can literally make anything up you want for y. You want it to be 0? Fantastic. You want it to be -1? I love it. Want it to be 27? Perfect. Want it to be 1,472? Excellent. As long as x is always 2, we don't care what y is. And so now we can plot that. We're not going to plot 2,1472, and we're also not going to plot 227. So I was playing around, but you get the idea, I hope. So 2, 0. X is out at 2 to the right, and y is at 0, so it lives right there. And then we have 2, -1, which is right here. And maybe we should add a more reasonable one just to check ourselves. 2, how about 3? So let's see, we're out at 2 and then up to 3. Yeah, so this thing is going to be on this line right here. Everything on this line is where x equals 2. That's what x equals 2 looks like. So equations, linear equations can look kind of funny. They can look like this right here, where both the variables are together on one side. They can look like this, where y is on one side and x is on the other. And they can look like this, where there's only an x or only a y. These are all equations of lines, and we're going to be learning more and more about these as we go along. But for now, build a table and graph that line. We're going to do one more just to be sure we have the idea. I wanted to do a fairly complicated one so that we could, explore this idea. So the first step is to make a table. We got your x's, we got your y's, and let's do like that many. So let's choose 1 for x just to make our lives easier. So that would mean that we have 4 times 1 plus 2 times y equals 8. Remember, we're just taking that value for x, plugging it in. Oh, my screen stopped working. What's going on there? Oh, don't do this. All right, I might have to pause this for a second until the board starts working. I'll be right back. Okay, I'm back. All right, so we plug that 1 in for x, and let's start rolling. So 4 times 1 is 4 plus 2y equals 8. And then we're going to subtract 4 from both sides, remember? Creating this cancellation. And then we have 2y equals 8 minus 4, which is 4. And then we're going to divide both sides by 2. This is the stuff we did last semester. And then y equals 4 divided by 2, or 2. And so when x is 1, y is 2. All right, let's get rid of this mess. I wish you were here with me because then I'd ask you what value you wanted me to put in for x. We could make up something, but let's try 0. Let's see what happens. So now we have 4 times 0 plus 2y equals 8. Well, 4 times 0 is 0, so 4 times 0 is 0, so we have 0 plus 2y equals 8. Subtracting 0 from both sides this time gives us that 2y equals 8 because these cancel. Dividing both sides by 2, we get y equals 4. So when x is 0, y is 4. Okay, let's do a couple more. Just because it's complicated doesn't mean the steps change. We're just picking a value for x and solving for y. So shall we try a negative? How about -1? 4 times -1 this time plus 2y equals 8. 4 times -1 is -4 plus 2y equals 8. Now we have to add 4 to both sides. That creates this cancellation, and we have 2y equals 8 plus 4, which is 12. Dividing by 2 gives us y equals 6. All right? Let's do one more. I don't know, what do you think? -2? Why not? Or +2? Shall we do +2? Oh, there goes my alarm, you guys. What time is it? Oh, it's time to go home. Wow, I'll finish this up. So let's do this. We have 4 times 2 plus 2y equals 8. We drop that 2 in for x. So let's see, get rid of this. I don't want that to confuse us. 4 times 2 is 8 plus 2y equals 8. Subtracting 8 from both sides. Oh, this is fun. These cancel, and we have 2y equals 8 minus 8, or 0. That's okay. Let's divide by 2. That creates this cancellation, and we have y equals 0 divided by 2, which is 0. And so when x is 2, y is 0. And now we can plot those points. So 1, 2 means you go 1 unit to the right and 2 units up. So there it lives right there. 0, 4 means you don't go anywhere left or right, but you go up 4. So 1, 2, 3, 4, there it is there. -1 would be -1 to the left and then up 6. Uh-oh. That's going to be up here somewhere because here's 5. So 6 is going to be right up here somewhere. And then 2 to the right and 0 lives right about here. Okay. So then let's connect those as the line that they are. And there you have it. So even with complicated looking equations, you still basically just take a value for x, plug it in, and generate a value for y. Now this is a lot of work because you have to solve a lot of equations. Can I reassure you about something right now? It's going to get easier. This is like the hardest way of graphing lines. There's much easier ways. But I wanted to kind of show you the hard part first so that you could visualize it so that when it gets easier, you'll be relieved. All right, you guys, I hope you have a wonderful day. Your practice is on quizzes. Click that link and answer those questions. Have a great day. See you soon. Bye.